touch the moon, I do. I do. I wanna swing, swing, swing with you. Take you away across the blue lagoon. Lagoon.
Hello and welcome in, everyone. My name's Brian, and I'm back. It's been a little while. It's been about a week since we've gotten together. I think it was, well, last week, Thursday, I think, was the last time we were together working on some math stuff. But I'd like to do a little bit of mathematics today. Gonna kind of keep on trucking through the Euclid Contest 2018. Hope you're all doing well. Feel free to give me a little update on how things are going on your side. Today has been a pretty productive day so far. I went over to a friend's place. I built a corn garden of all things today, which was kind of fun. Which is why I'm running a little bit late. But that's okay, we made it, we're here. So as you know, if you head over to the CEMC website from the University of Waterloo, they have all of their past contests available, and specifically we're working on the grade 12 contests, the Euclid contests, and currently I'm working on the 2018 version of that contest. So I'm going to get question 5 set up as Twitch runs some ads. Alright, so number 5A from the Euclid contest. Let's see what we're getting ourselves into here. Looks like some geometry, which you know is my arch nemesis. Okay, so the perimeter of an equilateral triangle, PQR, is 12. And the perimeter of a regular hexagon is also 12. Imagine, like, having a child and naming your child this. Stuvwix. Anyway, what's the ratio of the area of the triangle to the area? The areas. Okay, the area of the triangle to the area of the hexagon. Now, I have a strange feeling that something's going to be inscribed here. If I build a regular hexagon, if I can I do that? Let's pretend that's regular. Hexagon is 6 sides, right? 6 sides? So not a stop sign. And we also have an equilateral triangle. Now, I feel like that equilateral triangle, could we argue? Could we argue that it must be this? You know, like, kinda Zelda style? Would those two things have the same perimeter? Would they have the same perimeter? I feel like this is now turning into a GeoGebra thing. Okay. If the perimeter is 12 and we take the perimeter and we divide it by 3, that means each of these side lengths is 4. Now, if I take 4 and I divide that into 3 equal sized pieces, each one of these must be 4 over 3. Now, 6 times these, right? 6 of these sides 1, 2, 3, 4, 5, 6. 6 of these sides would give us 24 divided by 3, wouldn't it? Which is not 12. Okay. So it's not quite what I'm looking for. Well, let's tackle this a different way then. Why don't we start with the regular hexagon and see how we can build an equilateral triangle around it? Because this regular hexagon is just going to be composed of a bunch of equilateral triangles, isn't it? So if we make this hexagon and find the center, all of these things are going to be equilateral triangles. I don't know if that matters quite yet. But let's try to find the side length. So if we call this S, and I say that the perimeter is 12, then 6 S's should be equal to 12, so each side should be 2 units long. I think that makes sense. I'm happy with that. So the other thing we want to think about is if we have this equilateral triangle, we just need to find the areas, don't we? Okay, this perimeter is 12. And this is S. There are 3 of them, so 3 S's would be 12, so each S is equal to 4. So knowing that information, is it possible to find the area of both of these things? Definitely the area of the triangle will be pretty easy. We just need base times height divided by 2. So this is 4, this is 2. So I guess we could Pythagoras out the last side. So we know that 4 squared, or the hypotenuse squared, should be the height squared plus 2 squared. So 16 should be the height squared plus 4. So the height squared is 12. So the base of my triangle is 4. The height of my triangle is the square root of 12, and I need to divide that in half. So the area of my equilateral triangle should be 2 times root 12, but I think we can do a little better. So let's take out that square factor of 4. So we're going to get another 2 out here, and then we'll get a root 3. So it's going to be 4 root 3s will be our area. Now I have to try to do the same thing over here. I forget how to find the area of a hexagon. Isn't it just 6 triangles? Okay, I don't know the area formula right off the top of my head, but those should be equilateral triangles, and we know that S is equal to 2. So this distance here is going to be 2, this distance here is going to be 1, and we can probably Pythagoras out the height again. So 2 squared should be equal to the height squared plus 1 squared, so 4 is equal to h squared plus 1, and the height squared, is 3. Okay, so we're going to get square root 3. These are 1, 2, root 3 triangles. I didn't see that in the equilateral triangle, but I probably should have known that. So these are 1, 2, root 3 triangles. So the area should be 6 times the area of the triangles. So 6 times the base, which is 2, the height, which is root 3, over 2. So I think we're going to get 6 root 3s as the area, of the hexagon. So now we just need to find the ratio of the area of PQR to the area of our hexagon. So we need 4 root 3 to 6 root 3. Obviously the root 3's, we can divide that out, where there's a factor of 2 here as well, so we get a factor of 2 to 3, or a ratio, I should say, of 2 to 3. So I'm going to roll with 2 to 3. That feels appropriate. That feels like it's about right. So let's roll with that. Alright, I'm not going to lie, I wasn't exactly sure how I was going to solve that question, but it turned out to be not as bad as I thought. Alright, let's move into 5B. This looks... You know it's going to be an interesting day when they throw the old pencil and paper icon at you. Alright, so Euclid, this is 2018, number 5B. Let's see if we can do some more geometry today. So, question 5B, another geometry question. We have a diagram here. AOB is a sector of a circle. It's 1/6 of a circle. Okay, A to O or O to B, both of those, BO. Both of these are 18. So the radius of our circle is 18. The sector is going to be cut into 2 regions. And the cut starts at point A and goes to point P. Really, such that the areas of the 2 regions are equal. That's weird. Kind of cool, though. Okay, so the triangular region is the same as this like weird circular arc region. So that's all we know. I guess the other thing that might be important is, yeah, we do have a couple of lengths here. This is 18, and we know that this big length way over here, too, should be 18. And so we need to figure out the length of O to P. We need to use, I feel like we need to use this first. 1/6 of a circle with radius 18. So how big? A1 plus A2. So these 2 areas added together is 1/6 of a pi r squared. So we need 1/6 of pi times 18 squared. Not sure exactly what that is. I should know my square numbers, but 18 times 18, so 324. That is probably divisible by 6. So this is 54 pi's. Man, I wish I just had like 1 pi right now. I don't need 54 of them. Okay, but that does give us some information. 54 divided in half is 27. So we know that A1 is equal to A2, which is equal to 27 pi's. Okay, so we've used the 1/6 of a circle. We've used the areas are equal. And we technically have used the radius being 18 as well. Now I wonder if we can zero in on region A1. So, can we work in this? Can we work with just this triangle? Because I do know this side length, although I don't know the distance from A to P. That's going to be the problem here. But you know what I probably could find? I probably could find this arc distance, couldn't I? I bet you I could find that. Because I do know that this full distance is 18, right? That arc length is just going to be 1/6 of the circumference, right? Right, if this is 1/6 of the circle, I would assume that that's going to be 1/6 of the circumference. Is that a bad assumption? And do we need that is the other question. Do we need that arc length? I don't know if we're going to need that. Now I'm wondering if we should tackle this with trigonometry. How do we get the area in here, though? That's what I'm wondering. Because, like, I mean, we can do base times height over 2, but I don't think that's going to be super helpful. I can't see how I can easily bring, like, the height into this. I mean, we have a base. We could use base 18, or we can use base OP. But I just don't see how we can easily bring the other factor in. So, all I really have... No, isn't there a way... Okay, isn't there a way to calculate the area of a triangle using trigonometry? No, I'm thinking that must be with vectors. But shouldn't it be the same thing? I mean, because we could probably find this angle, right? This is just 1/6. This is 1/6 of the circle. Sensation, hello. Always popping and dropping the dad jokes. Much appreciated. I made some, I was planting a corn garden today, and I definitely 100% made corn jokes today. I made some very corny jokes with my friends today. It was great. It was a good time. I did not know how to count milk until today, but now I know that things must be calculated. How are you doing, man? How are you doing? How's the weather up there? That's always the real question. Can I trigonometrize this? Can I trig this? Can I trig this and make this work? What's 1/6 of 360 degrees? All right, angle O is 1/6 of 360 degrees. Is that 60 degrees? I'm pretty sure 60 degrees. That is a 60-degree angle. Still too hot. Oh no. You guys are having like a little heat spell up there? What's going on? It's like super chilly here in BC. Well, it's not that cold, but we've had like cloud cover, rain. It's only going to be like, I think it's only supposed to be like 15 or 16 degrees tomorrow. We've been having like 35-degree weather. And the fact that it's hot at midnight, that's the worst. Oh, I hate trying to sleep when I'm hot. Ugh. That and sand. Sand between my toes. I hate sand between my toes, too. I'm getting better. But I just... There's something about sand in my toes that I don't like. Because it's impossible to get them all out after you leave the beach. It just follows you. The beach comes home with you, and I don't like it. Is an angle helpful, though? Is an angle helpful? I don't have a 90-degree angle, so I can't directly sine or cosine something. I could cosine law something, or sine law something, I guess, but I don't know if that's helpful. Because I don't know the relationship between OP and AP. That is fair, yeah. So he says it's summer, houses are designed to keep heat in. That's fair, yeah. So I suppose when the summertime does come and the houses are designed to keep heat in, that's a potential issue. So how does it work? Do you have to just open up like a bunch of windows and turn some fans on? Is that the best option we have, other than obviously air conditioning? But if you don't have air conditioning, I suppose you just invest in a lot of things that blow air around. No, I don't. Okay, I don't think that would be a perpendicular. Okay, let's just say for funsies. Okay, let's say for fun, let's get rid of all this. So for funsies, let's say that the area of my triangle is 27 pi. And the area of my triangle is base times height over 2. There are a couple different ways we could do this, but they all have to come out to 27 pi. What if we take the base to be OP, and we take the height to be A, whatever this is. Oh, that's interesting. That's going to get me back to 54 pi. So OP times AM is 54 pi. And that's the entire area of A1 and A2. Buzzle Andy, hello. How's your day going? Geometry, yeah, we're working on a Euclid question. I have a little circle sector and I'm trying to find the length of O to P. I'll let you read the question. See what I've done so far. Crack a window open, leave the blinds down. Oh no, not even any fans? You need to start investing in some rhubarb. My rhubarb is going crazy. You can cut the leaf, you'll just flatten it, shellac it. You can just make your own portable fan made out of a rhubarb leaf. I think that'd be cool. I'm into it. I'm into it. I don't think that's going to be it. I want this to be perpendicular here at M. Right? I want that to be the height, but I don't think that that's necessarily going to cut this triangle into two equal-sized pieces. It doesn't have to. It could, but I don't think it has to. I mean, if AP was 18, it probably would, I suppose, right? This would have to be isosceles. Oh, wait a second. Wait a second. If O is 60 degrees, then that must mean this one up here must be 30 degrees. And now I do have a little right-angled triangle I could do some work with, I suppose. Although O to M doesn't really help me out that much either. What is that? Sauce, welcome on in, brother. How you doing? School been making me feeling like I'm getting a body slam. Yeah, formal education do be like that sometimes. I agree, yes. Yeah, every once in a while you'll just be minding your own business and wham, boom, and there it comes, mathematics with the old elbow. Just sorry to hear that. My words of advice to all high school students are, it will be over soon. It will be over soon. That's what I always tell high school students. You're almost there, and then the world becomes a much larger and better place. 2 weeks to finals. That's coming up pretty soon. I guess it is June, isn't it? Jeez. I can't believe it's June 13th already. That's crazy. Seems crazy to me. Yeah, so all the kids you guys are going to be out of school soon. Oh my goodness. Just in time for the crazy heat of summer, right? Or wait. You going into rainy season, aren't you? If we're going into summer in northern hemisphere, then you're going into rainy season in the southern hemisphere. Is that how this works? I probably shouldn't have skipped my geography class. I feel like it's something like that. I'm telling you, this OP, I'm not feeling very OP with this question today. Yeah, I mean, okay, we got the area of the circular arc. We have the angle. But I don't think there's an easy way to do a base times height over 2 and make this work. I don't think the Euclid contest would want me to know... I don't think they would want me to know Heron's formula, would they? But that's not, I don't even think that's going to be helpful because I only have one side length. Now I'm kind of curious. Did they extend the circle? Like, what would they do? Would they like make this 90 degrees and like bring this over and try to kind of keep on? Yeah, that's what I'm wondering. Maybe we have to just kind of extend the circle here, make it work. Because I don't think just looking at the triangle itself is going to be helpful. But maybe if we look at 4 times the triangle, it'll be helpful. What do you say here? Already melting from the summer heat, and then you get a sucker punch of extreme rainfall at noon. What a weird time to have a sucker punch of extreme rainfall. Noon. I mean, I like the rain, but I guess maybe not if it's a monsoon. Oh, what? Wait. Um... 3/6 would get me all the way out to here, right? So if this is like 1/6, then like 2/6 is like, it's like something weird like this, right? So here's kind of an upper half circle. It's not drawn to scale. But point P is like somewhere here.
Time for a pop quiz.
What if we just like reflected that and flipped it over? Would that help? Hi, Reese. Hello. Like, could we reflect this and make this work? Because then it would like turn into something like this, wouldn't it? Like if I like copied it and like mirror image flipped it. Actually, it's not going to be perfect. I think it's going to like come up and then kind of like go like, it's not going to be a straight line. I am the worst artist ever. Okay, so it's going to be something like this, I think, right? It's going to do something weird like that. But I think we could probably, like, couldn't we realistically do something like that? Now I just want pizza. Oh. Just put some pepperoni on there. How do we feel, like, is pineapple on pizza permitted? Like, is that a thing that we can do? I feel like sometimes when I suggest that, people get mad at me. Yeah, that's the issue, Sauce, is like AP doesn't make a really nice angle, but I do think that if we put like 2 of these together, we can probably like have this one like come up to P. That sounds funny. This one can come up to P. And then it's gonna like go back a little bit, right? And it's gonna land at the corner of like wherever this other one ends up. I have no idea if that's going to be helpful. All I know is that each of the areas of these things is 27 pi. And it does give us a little bit more to work with this way. So this is O and this is P. We're looking for OP. We want the length of OP. And we do know these are 60-degree angles. I still don't know if that's super helpful. I guess, yeah, if you were to keep following this pattern, you would get a hexagon, wouldn't you? Because it would take 2 copies of this to get back to, let's say, A. And there are 6 sectors altogether. So yes, we would end up getting a hexagon inscribed. Ooh, that's actually kind of important, isn't it? We would get a hexagon inscribed inside of a circle. This could be challenging. It's not technically inscribed, I guess, isn't it? It's just something weird like this, where it's gonna like come over here and then like go to here. Yeah, it's not necessarily inscribed, I guess. I can't even draw this properly. Oh man. Okay. We gotta pull out the big guns here. You technically can get an OB times O. What, really? Okay. You can technically get an OB times OP if you. Okay, wait. I missed the other thing. If you draw from B to A. What? If you draw from B to A identical to AP. Whoa, okay, okay. So let's draw from, okay, do you mean like we need to connect A and B together? Or do you mean we take AP and move it over like this? So that they're the same, so that they're parallel. I think you mean connect them, right? Like this? Like AP, we draw from B. Oh, crisscrossing. Like AP. Oh, okay. I see, I see. You're gonna do something similar down here. And it's gonna cross at OA. Gotcha. Something like that. So we get a little like shoelace or something like that. And let's call that point M. Okay, I'm following so far. You can technically, okay, so we should be able to draw it. I got you. We should be able to technically draw it so that OB times OP is equal to OA times ON. Right. Yeah, we should technically be able to find this point M. In other words, I guess we're picking point M so that this length here and this length here are the same, and this length here and this length here are the same, right? This really now does start to feel a little bit like triangular lacing. Yep, OB and OA are the same. That's correct. Yep, so they're both 18. So that's definitely possible to do. That's going to give us an intersection point if that's helpful. to 2OP is equal to 1. I don't know about that. I can get behind that OP and OM are the same. That makes sense. We could probably even argue that AP necessarily has to be the same as BM. All these lengths have to be the same. I can definitely get behind that. It's 4 a.m. Why am I doing math? That is what I ask myself every morning at 4 a.m. Like, why the fuck am I up and why am I thinking about mathematics right now? I mean, this is an interesting idea, but I feel like I just need, like, I need one piece of information that is just not super obvious. I like that idea, and it reminds me of a really cool proof that you can actually prove. I think like the, what is it, like the sine law or the cosine? You can prove like I think it's the regular trigonometric ratios. You can prove like the sine double angle formula or cosine double angle formula using stitching like this. It's really, really cool. If you connect AB, oh, if we connect AB, we certainly do get an isosceles triangle. Do I need BM? Maybe not. Maybe I don't need any of this. Maybe I just do need to connect these two together. That's a thought. Since OB is equal to OA, we know that triangle OAB is isosceles. So we know that this is 60 degrees, and this angle and this angle must be the same. Is it equilateral? How do we know that AB is also going to be 18? Oh, is it because that's a 60-degree angle? Oh yeah, it's got to be equilateral, doesn't it? Oh, okay, that's crazy. Okay. Yeah, I got you, right? Like, hey Brian, how about you just realize that what's left over is 120 degrees and then divide that in half? Okay. So yeah, so it's got to be equilateral. Sure, all of this stuff is 60 degrees. Cool. Okay, that's something we definitely didn't have before. So we know the length of AB. Is that helpful? So I'll highlight again. Our goal is to find this length here, O to P. Here, I'll zoom out a little bit so we can see some of the information. So we know the circle sector is 1/6 of a circle. And we know the radius of that circle is 18. And we know the area of each one of the regions is 27 pi. And maybe I'll be a bit more specific about the region name. So one of the regions is triangle OAP. And one of the regions is kind of circle sector BAP. Can we 90 degree from A to OB? I don't see why we couldn't. Yeah, I don't see why we couldn't zoom in and do that. So if we want to 90 degrees, let's say it's around here, so we can, yeah, we can definitely do that. I don't see why we couldn't. Okay, let's call this M. That would divide our equilateral triangle directly in half. Now, wait a second. Let's be careful. Yeah, do we want this to be the half cut of the equilateral triangle? That would be a perfect half cut, right? Or the other option is we can do a 90-degree drop from A to... It doesn't matter. It's going to be the same height, isn't it? It doesn't really matter because there's only one perpendicular drop. Gotcha. So this is a unique cut. It's going to cut the equilateral triangle exactly in half. It's also going to be the height of triangle OAP. So the height of this equilateral triangle is the height of the triangle that we're looking for. We should probably be able to figure out the height of this equilateral triangle, right? Oh, sorry. I have my window open and it's really windy. And my door just slammed shut and I got a little scared. We're good, we're good. Yeah, sorry. You guys probably can't hear anything that's happening outside because I usually have the microphone pointed towards my mouth rather than outside. But yeah, it got really windy all of a sudden. Okay, can we find the height of this triangle? We should be able to. Equilateral triangles, when we slice them in half, are always... Okay, so if it's 1, 1, and 1, 1, 1, and 1, and I cut it in half, this is going to be a half, and this is going to be... So let's just multiply everything by 2. It's a 1, 2, root 3 triangle, isn't it? We just talked about this in the last question. So if I multiply everything by 2, then that should be root 3. So this should be root 3. Root 3, wait. If the side length is 18, how many root copies of root 3 do we have? 9 of them? 9 root 3? So AM is 9 root 3s. Is that true? Because O to M would be half 18. And if I do the Pythagorean theorem, it says that OA squared should be equal to AM squared plus OM squared. So O to A is 18 squared. A to M is the thing we're trying to find. And OM should be half of, should be 9 squared, right? Oh, Reese. I'll Well, we'll do one better. We got the old doggo cam. You know, we can zoom in and see what Reese's up to. Well, maybe that's not the most appropriate. Oh, Reese, what are you doing, buddy? You're not supposed to lay down like that, you big whore. Oh, that's funny. Oh, there he is. There he is. What a good boy. Oh, Reese, you're so funny. You're so... Don't you knock over my camera with that big tail of yours. Oh, that's hilarious. Anyway, let's see. So 324, 9 squared is 81. So 324 minus 81 is going to be 243. I need to take the square root of that. So square root, nope, that's cube root. Square root of 243 is 9 root 3. So I'm happy with that. I think our poor doggo is as hot as Sauce and Sensation. Poor Reese. He's a big man in a hot part of Canada. Professor Bork. I like that. That's cute. Okay, so the height of equilateral triangle is 9 root 3. The height of OAP must also be 9 root 3, right? I think that's the way to do this. So in triangle OAP, we have base times height over 2, which is 27 pi. And the base is OP. The height is 9 root 3s. And so now we should be able to solve for the length of OP. Oh my goodness. Wow, you guys are great. Like, man, thank goodness there are some smart people here, because I am clearly not smart enough to be able to do this. So OP is 54 pi over 9 root 3 is my best guess based on some of the stuff we've talked about. Can 54, I feel like that's divisible by 9, right? How many pi's are up there? How many pies do I get today? School in a half hour, gonna go dunk in an ice shower and to regulate your body temperature. Okay, I mean, good luck. Best of luck with school. Thank you for all the help today. I'm probably gonna be signing off shortly as well. We have the Stanley Cup finals happening tonight here in Canada. Well, not in Canada, but in North America. I'm pretty excited. We got some Canadian players on the Las Vegas Knights, so I'm gonna go watch the game tonight. Asian math sense is tingling. That's hilarious. Is this 6 pi over 3? Is that how it works? 6 times 9 is 54, I think, right? Okay, let's take a look. Let's take a look at our solutions. Let's see how we did. All right, 2018 contest. We're looking at question number 5. We were trying to find, I believe, ratio. So I just want to go, yeah, ratio is 2 to 3. That's what I thought. So I did that the long way, but that's okay. I'm very curious about this question, though. Okay, so area, yep, is 54 pi. Each one of the things is 27 pi. Perfect. We know that one of those angles is 60. We drop a perpendicular. Look at that. Oh, they did AOT as a 30, 60, 90 triangles, but either way, they were able to get the height. That's the important part here, right, is to get the height. So that OP is 2, what? Oh, they just simplified it. Okay, that's what I got. 6 pi over root 3. I didn't rationalize, that's my own fault. So 2 root 3 pi. Perfect. Okay, nice. Nicely done. We didn't even have to pull out. I thought I was going to have to use GeoGebra. We did not have to use GeoGebra. We are champions. Look at us go. Yeah, we went a little overkill, I think, with the equilateral triangle, but I'm okay with that. It made sense. I was happy with our solution. Look at us go. We are mathemagicians today. Look at us. Still correct. You got it. All right. Thanks for hanging out today, guys. I'm gonna, I think, head out. And I'll try to be back a little bit later this week, but like I said, my schedule has been just really hectic the last little while, so it's always a little bit hit or miss whether or not I can make my actual scheduled times. But very happy I was able to get together with you guys, and yeah, I mean, you obviously are learning something over there. Sauce, you obviously know what you're doing over there. You too, Puzzleandy. Good to see you. Enjoy your evening. I know it's a little bit later here, but I gotta go drink some beer. So I will see you guys later. And stay positive, guys, and enjoy the rest of your day. We will talk to you a little bit later.